Okay, in this one here, we have manufacturer claims the mean lifetime of its fluorescent bulbs is 1,000. Homeowner selects 40 bulbs and finds the mean lifetime to be 990. Population standard deviation of 80. Sigma is 80. We're still with a z-test because we have sigma here. Test the claim. All right, H sub A. Mu equals 1,000. That has to be null. Mu not equals 1,000. That is our alternative, and hence this is a two-tail. Okay, so let's get our information together here. There's our n of 40, and here is our x bar here. So I need the z as x bar minus mu over sigma over the square root of n, which is x bar minus mu 990 minus 1,000 over 80 over square root of 40. That's approximately negative 0.79. Okay, so that's the negative 0.79 there. We also need to know 0.79 over there. So remember, now we have two different regions here. So what I'm going to do is I'm going to find the area of the left region and then double it because I need to account for both regions. So now let's go to Excel. All right, so equals norm dot sdist. I'll use the negative 0.79. All right, and so I get that 0.2148-ish. And then I'm going to do 2 times that, 0.4295. 0.4295 is the end result there. All right, so this was about 0.2148, but when I double it, I'm going to get the p as twice that, and it's about, what did I say, 4295 or 4296, depending on how you round, 0.4295. And don't worry about the small rounding errors there. All right, so this p-value then of 0.4295 compared to the alpha of 0.05, oh, well, that's greater. So I fail to reject. H naught. Okay. So let's make a conclusion here, an interpretation. Our claim was in the null hypothesis, so I'm in a rejection mode here. I failed to reject it, so there was not enough evidence to reject the claim. There is not enough evidence, at 5% significance level to reject the claim. All right, find the standardized test statistic T for a sample. So now we're using T, notice, because we do not know the population standard deviation. We have the sample information. All right, so the standard error, the sample mean. Okay, so this time, if we calculate T, it's very similar. It's x bar minus mu, but over S over the square root of n. So that would be x bar is 16.5 given. The mu, so they told us that here is the null hypothesis, means that the mu must be 17.4. and S 1.3 over the square root of 10, and that would give me about negative 2.189, and so that is our t. So let's do another hypothesis test here. Metropolitan Bus Company claims the mean waiting time for a bus during rush hours is less than 8 minutes. Random sample of 20 meeting times has a mean of 6.6 with a standard deviation of 2.1. Notice the standard deviation is coming from the sample. There's no mention of population. So that's an S of 2.1. This is a t-test. Okay, so let's see. So let's set this up. Mean waiting time is less than 8 minutes. Mu less than 8 in the alternative, that's the claim. Mu greater than or equal to 8, that's the null. We have an n of 20. We have an x bar of 6.6. We already said the s is 2.1. And we have an alpha of 0.01, 1% level of significance. And remember that for a t-test, it's important to know the degrees of freedom. So the degrees of freedom is 1 less than the sample size, so 19 for that. Okay, so remember, t-test here. So I calculate my t. So that would be 6.6 minus 8 over 2.1 over the square root of 20. Just use n there, regular n. And that gives me about negative 2.981. Oh, so what were we doing here? I didn't draw the diagram here. Mu less than 8 in the alternative. That means we're doing a left tail here. And we found that the t was negative 2.981. So I need to find this area here. And that I'm going to need to go to Excel to look it up. Okay, so let's get rid of this. And this time we're going to be doing the t distribution. And we are doing a left tail, so that's the regular one. All right, we had a negative 2.981. And degrees of freedom, we said was 19, 1 less than the n of 20. True. 0.0038. 0.0038. And so this is left tail, so that is our P. So 0.0038 as our P. Compare that to our 0.01 alpha. That is less than 0.0038. So we're going to reject H naught, P less than alpha. That will let us conclude this as we rejected H naught, claim is in the alternative, support mode. We rejected and got to the alternative, so there is enough evidence at 1% significance level to support the claim. Okay, good. The difference there was a t-test instead of the z, again, because we had the sample information, not the population standard deviation.